Hello, you are most welcome. I'm teacher Ivan from Wunna Educational Services. I welcome you to our lesson. In today's lesson, we shall be doing chemistry. And in chemistry, we are looking at particularly mole concept. Yes, under mole concept, we look at calculations. So we shall start with the atomic mass and the molar mass. Atomic mass is defined as the mass of one mole of atoms. The mass of one mole of atoms. For instance, the atomic mass of oxygen is given by 16 grams. And the molar mass is defined as the mass of one mole of a compound. The other one was 1 mole of atoms. That was atomic mass. Molar mass is the mass of 1 mole of a compound. Let's say the molar mass of carbon dioxide. Carbon dioxide is a compound of carbon and oxygen. So the molar mass of carbon dioxide, we shall get the atomic mass of carbon plus the atomic mass of oxygen, but there are 2 molecules of oxygen. So that gives us 12 times 1, that is for carbon, plus 16 times 2, that's for oxygen. Then we get a total molar mass of 44 grams. That is how we get atomic mass and the molar mass. Still another example on molar mass, we have molar mass of water. The molar mass of water is given by twice the atomic mass of hydrogen, that is 1 times 2, plus 16 times 1, since it is 1 mole of oxygen. So that gives us the molar mass of water as 18 grams. So that is how we get molar mass and the atomic mass. We have an NB which says that sometimes the formula mass and the molecular mass are used instead of the molar mass. Yes, sometimes we use molecular mass or formula mass instead of molar mass. Molecular mass is used especially for substances which exist as moles. That's where we use molecular mass. And let us look at examples. We have examples. Example 1 says, determine the molar mass of copper 2 carbonate. So copper, the atomic mass of copper is 63.5, that of carbon is 12, and that of oxygen is 16. So if we are to determine the molar mass of copper 2 carbonate, then we shall get the atomic mass of copper plus that of carbon and the 3 times that of oxygen. So which gives us a total of 123.5 grams. That is how we get the molar mass of copper. Let us also look at example 2, where we are told that a sample of copper has a mass of 3.2 grams. They want us to calculate the number of molecules, the number of moles of the atoms of copper present, and also the number of atoms present in the same sample. Okay, so if we are told we are to get the number of moles and atoms in 3.2 grams, then let us first get to know how many moles are in copper, because we've said that the molar mass of copper is 63.5 grams, and that means that 63.5 grams contain 1 mole of copper. That is what is in 1 mole of copper. Then they are asking for the number of moles in 3.2 grams. So if 63.5 contains 1 mole, what about 3.2 grams? So this will contain, let's say X, because we don't know. And now we can say we take ratios, that is 63.5 over 3.2. This equals to the 1 mole over X moles. Hence, when we cross multiply, we end up with 63.5x equaling to 3.2. We divide by 63.5, 63.5. We end up with x as 3.2 divided by 63.5, which is 0.05. So those are the number of moles in 3.2 grams. We say therefore 3.2 grams of copper contain 0.05 moles. So that is how we can answer such a question if at all they are asking for the number of moles in a certain mass of a substance. The other number was asking for the number of atoms. Yes, number of atoms in these moles or in the 3.2 grams of copper. We know that 1 mole of copper contains 6.02 exponent 23 atoms. Those are the number of atoms in 1 mole of copper. What about 0.05 moles of copper? These ones contain X. Still, we can find the number of atoms by taking ratios. This is 1 over 0.05 equaling to 6.02 exponent 23 over X. Whereby, when we cross multiply, we end up with X equaling to 0.05 times 6.02 exponent 23. So that gives us 3.01 exponent 22 atoms. So that means that they are 3.01 exponent 22 atoms in 3.2 grams or in 0.05 moles of copper. That is how we shall answer such a question. That has been number 2. Let us go to another example. That is number 3. Number 3 is asking us to calculate the number of hydroxide ions contained in 34 grams of hydroxide. Yes, if we are to get the number of ions contained in 34 grams of hydroxide, then we need to first get the molar mass. We need to first get the molar mass of the hydroxide. This is how we shall get it. That is the symbol of hydroxide. And now from this, the molar mass of hydroxide is given by this is 16 times 1. 16 is for oxygen, plus 1 times 1, that is for hydrogen, which gives us 17 grams. So that is the molar mass of hydroxide ion. Then that means that the 17 grams of hydroxide contains 1 mole. What about the 30? Because in the question we are asked to calculate the number of hydroxide ions that are contained in 34 grams of hydroxide. So if 17 contains 1, then that means that 34 grams of hydroxide contains X, which gives us 17 over 34 equals to 1 over X, hence giving us 17X equaling to 34 by 17 by 17. That gives us X as 2 moles. So that means that 34 grams of hydroxide contains 2 moles. But the question is asking for the number of ions, and therefore 1 mole of hydroxide contains 6.02 exponent 23 ions. What about the 2 moles now that are in 34 grams? The 2 moles of hydroxide contain to be X. Still we take ratios, which is 1 over 2 equals to 6.02 exponent 23 over X. So when we cross multiply, X equals to 2 into 6.02 exponent 23 ions, which gives us a total of 1.204 exponent 24 ions. And therefore we shall conclude that 34 grams of hydroxide contain 1.204 exponent 24 ions. So those are the number of ions contained in 34 grams of hydroxide. So we are still looking at atomic mass and molar mass. Otherwise, that has been for the first lesson. Please don't forget to subscribe and hit the bell so that you get notified whenever we have a new lesson. Otherwise, I hope to see you in our next lesson. Bye bye.